Okay, Chapter 4, Discounted Cash Flow Valuation. In your previous coursework, this chapter may have been titled Time Value of Money. Key concepts and skills. Be able to compute the future value and or present value of a single cash flow or series of cash flows. Be able to calculate the return on an investment. Become more proficient. Hopefully you're already somewhat proficient using a financial calculator. And also we'll do some work with spreadsheets in this chapter as well. Excel has many functions that are very helpful with this type of analysis. Understand perpetuities and annuities. So chapter outline, first is valuation. Do a one period case, a multi-period case. Talk about compounding periods, simplifications, loan amortization, talk about the value of a firm. So valuation, one period case. So if you were to invest in at $10,000 at 12% for 1 year, investment would grow to 11.2%. The interest, the $1,200 would be interest, so 10,000 times the 0.12 or 12%. $10,000 is the principal, so 10,000 times 1 would give you your principal repayment. So total 10,000 plus the 1,200, 11,200. So calculated as 11,000 or 10,000 times 1.12 is equal to 11,200. So the total amount due here is called the future value. So one period case, and in the one period case, the formula for future value can be written as future value is equal to the present value. Let me see if I can get that. There we go. Multiplied by 1 plus the interest rate. So in this case, we're talking about an annual rate, but we'll talk when we have different compounding periods. This is what's called the periodic rate, and the annual. In this case, period is a year, so it's annual. But if it was monthly or quarterly or daily or semi-annually, we'd have to make an appropriate adjustment, which we'll talk about as we move forward. So present value. So present value is just the opposite of future value. So if you were promised $11,424 due in 1 year, again, interest rates are 12%, your investment would be worth $10,200 today. So another way to say that is if your required rate of return is 12%, the fair price for that would be $10,200. All right, there. So the calculation, the $11,424 divided by 1 plus the 12% interest rate is equal to $10,200. So if it was an obligation, the amount the borrower would need to set aside today to be able to meet the promised payment of $11,424 earning 12% is the present value, and the PV. So just a note, the $11,424 is the future value. So present value 1 plus R. So this is the future value formula. The present value is just, we'll show it here soon, but in next page, I believe. So present value is just equal, for present value of a single payment is equal to the future value divided by 1 plus R. So, one period case, the formula for present value can be written as PV, present value, is equal to C1 being the cash flow at that future date, and again 1 plus R being the interest rate. So net present value, we'll talk about this more in chapter 5. We'll talk about net present value in depth. So net present value of an investment is the present value of the expected cash flows less the cost of the investment. So if an investment promises to pay you $10,000 in 1 year on it, and you can buy it for $9,500, your rate of interest is 5%. So should you buy the investment? So calculate the net present value. So we have our $9,500 cost, and then the present value of the cash flow is $10,000 divided by 1 plus the interest rate, 1.05. So that's $9,523.81. So the present value of the cash flows minus the initial cost as an NPV, or net present value. Most people just refer to it as NPV, of $23.81. The decision rule here is if this is greater than 0, you would accept or invest in the project. So the present value of the cash flow is greater than the cost. So in other words, the net present value is positive, so investment should be purchased. Net present value, another example. So in one period case, the NPV formula can be written. The NPV is simply equal to the cost plus the present value, or the present value minus the cost, however you want to say it. It's easier for me to say present value minus cost, just makes more sense to me, but however you'd like to say it. If we'd not undertaken the positive NPV project that we talked about on the last slide, so if we'd invested our $9,500 at 5%, so the future value would be actually been less than $10,000. So look down here and below. So the future value of our $9,500 invested at 5%, so multiplied by 1.05, it is $9,000. That's $9,975, which is less than the 10%. $10,000, sorry. So we would actually be worse off had we invested and not chosen to invest in that project, which is a decision that many corporations will make. They have to decide which is going to be the most valuable for the firm. That's what the purpose of much of the analysis will do, especially in Chapter 5.